How fast someone walks can tell us more than just their speed. It can predict falls, gauge recovery, and even hint at overall health. In just 10 meters, we can gather powerful data that guides rehabilitation and tracks progress. In this video, we will be demonstrating how to perform the 10-meter walk test.
By the end of this video, you'll be able to accurately perform and score the 10-meter walk test, understand its clinical relevance and application across patient populations, and identify key psychometric properties, including validity, minimal detectable change, and cutoff scores for different functional levels. Let's begin with when and why this test is used, followed by step-by-step instructions on how to set it up and perform it correctly. This test measures walking speed over a short distance and is a quick, reliable way to assess mobility, balance, and gait. Clinicians often use it with individuals who have neurologic or orthopedic conditions, including Parkinson's disease, spinal cord injury, stroke, and other neuromuscular disorders. It's also commonly used to track mobility changes in older adults. Gait speed has even been referred to as the sixth vital sign, as it reflects overall health and can predict functional decline, falls, and even mortality.
To begin, a 10-meter path is marked on a flat, straight surface. The setup includes 2 additional meters before and after the measured 6-meter section to allow for acceleration and deceleration. The timing starts once the individual passes the 2-meter mark and stops at the 8-meter mark. This ensures we're measuring steady-state walking speed rather than the effects of starting or stopping.
You can use a stopwatch or your phone to record the time. Each participant completes 2 trials at their normal walking speed and 2 at their fastest safe speed. Assistive devices like canes, walkers, or braces may be used if they reflect the person's usual level of function. Your patient may also need some level of assistance, so make sure to document whether an assistive device or assistance level is required. Don't forget to add a gait belt to your patient for safety purposes. So today we're going to perform the 10-meter walk test. We're going to start at the first set of cones, and we're going to walk until we reach the second set of cones at a safe, comfortable pace. When I say begin, we'll start walking. We're going to do 2 trials at a safe, comfortable speed and 2 trials at a fast, safe speed. Okay, ready? Yep. All right. And then I will be holding onto the gait belt just for guarding, but she doesn't appear at the moment to have any deficits. All right. Begin. All right. Begin. Perfect. Next, we're going to perform 2 trials at your fastest safe speed. Okay. Begin. Begin. Perfect. Now that we've completed the test, let's calculate the gait speed.
To score the test, we first take the average time of the trials for the normal and fast walking speed. Then, divide the distance, 6 meters, by the average time to calculate gait speed in meters per second. For healthy older adults, speeds under 0.7 meters per second is indicative of increased risk of adverse events. For patients with stroke, speeds under 0.4 meters per second suggest limited household ambulation, and speeds between 0.4 and 0.8 meters per second indicate limited community ambulation. Speeds above 1.0 meters per second are typical for full community ambulation and are associated with greater independence and better health outcomes.
The 10-meter walk test has strong validity in populations with stroke, spinal cord injury, Parkinson's disease, and older adults. For stroke patients, the minimal detectable change is approximately 0.13 meters per second for comfortable pace and 0.18 meters per second for fast paces. In regards to predictive validity in patients with multiple sclerosis, the 10-meter walk test has excellent correlation with dependence in self-care at comfortable speeds, adequate to excellent correlation with dependence in mobility at comfortable speeds, and adequate to excellent correlation with dependence in domestic life at comfortable speeds. When looking at patients with spinal cord injury, 54 expert raters assess the validity of different outcome measures.
The 10-meter walk test was rated a 60% for validity or usefulness, while other tests, such as the 6-minute walk test, only received 37%. When looking at predictive validity in patients with stroke, the 10-meter walk test has excellent correlation with dependence in instrumental activities of daily living and excellent correlation with the Barthel Index.
Understanding these properties helps clinicians interpret changes in gait speed confidently, distinguishing real improvement from measurement error. This makes the 10-meter walk test an essential tool for accurately tracking patient progress and guiding effective rehabilitation.